So today we are identifying what are called proportional relationships. When you think of proportions, a lot of times, like we've been dealing with ratios and stuff, we've been dealing with cooking, and there was a video of some people buying paint. You guys remember that video that I had you guys watch on the e-learning? That's required, so just so you know, the e-learning is due by, at the latest, tomorrow. That's when the grade is taken for the e-learning, so make sure that that is done. But to identify proportional relationships, in order to get a certain color of the paint, they had to keep the ratios the same, and that's what it means to be proportional. Okay, so let's say we have a recipe and it calls for 2 cups of flour and a half a cup of sugar. Well, if I want to double that recipe, what would I need to do? Instead of 2 cups of flour, what would I need to do? 4 cups of flour. Instead of half a cup of sugar, I would need a full cup. So keeping those ratios proportional, right? 1/2 to 2 is equivalent to 1 to 4. Or if I wanted to triple that recipe, right? Instead of 2 cups, it would be 6 cups of flour. Instead of a half cup of sugar, it would be 1.5 cups of sugar. So that's the idea behind proportional relationships. Okay, so here's some vocab for you that we need. Proportion is an equation stating that 2 ratios are equal. So when you did that warm-up, and it was asking you, are these 2 ratios equivalent? What you were actually answering was, do these ratios form a proportion? And then it said that 2 quantities that form a proportion are called proportional. Okay, so they are proportional. So any of those questions on the warm-up that you got yes to on 5 through 8, those would be proportional ratios, or proportional relationships. So for instance, this is true, right? 6/8 is equivalent to 9/12. Why? Ashley? They both reduce to 3/4, which you have on your notes. These ratios are equal because they both reduce to 3/4. So that means that this is a proportion, because it's 2 ratios that are equal, right? So these 2 ratios are equal, therefore they are proportional. That's how you use those words correctly. Cool. So that's the vocab. So there's 3 ways to check to see if ratios are equal. First, just like we did on that, just like on the example, you can check to see if those those ratios are in simplest form. So we first want to see if the following ratios are equal or proportional. That's supposed to say proportional. I don't know if yours says proportions or proportional. What does yours say? Perfect. So it's just a typo on mine. By first simplifying both. So what do I need to do first? Well, let's look at the first fraction. What do I need to do to 12/18 to simplify it? Divide the top and the bottom by what? By 6. Okay? Because 6 goes into both of those, and I get 2/3. What do I need to do to 50/75? Divide it by, not 5, but divide it by 25. Okay? Divide both the top and bottom by 25, and I get 2/3. So what do we see? That both of those ratios simplify to be the same fraction. Since they both simplify to 2/3, that means that these are in fact proportional. Those ratios are equal. Yes? Okay. So the next one. We're going to do a bunch of examples and then you'll try some. Okay? So we'll do a bunch of them. We're going to do them fairly quickly. So what do I do to the first fraction or the first ratio? What do I need to do to that one? What do I need to divide the top and the bottom by?
10.
Well, 10 doesn't go into 12. It'd be 2. Okay? And I get 5/6. What do I need to divide this one by? Well, that one I'm not exactly sure what those common factors are. So you divide them by 2, and then you divide them by 2, and then you divide them by 2, and eventually you get that we actually divide them by what, Sam? 8, exactly. And we get 5/7. Ah, okay. So are these ratios equal? No, they're not equal. So we would use this symbol, which is the is not equal to symbol. Okay? So 10/12 is not equal to 40/56. And that's because they don't simplify to be the same thing. They're not equivalent, right? Questions on that one? Okay, so that's method number 1. Method number 2 is you can find a common multiplier. So read along with me. If the numerator and the denominator of one fraction can both be multiplied by the same number to equal the numerator and denominator of the second fraction, then the two ratios form a proportion, or are equal. It's saying, hey, why don't we not simplify both of them? Why don't we see if we can scale one up to be the second one? So what we say is, all right, 4/5. Can I multiply that by anything to get 32 over 40?
Yeah.
I can multiply it times 8, okay? Times 8 over 8. And we get that over here we multiply it, we get 32 over 40. Sweet, that's nice. So that means that in fact 4/5 is equal to 32 over 40. The way I often write that, just so you guys know, by the way, this is good to go. Sometimes I go like this. When they're written in proportional form like this, I go like that and I say times 8. You don't need to write that down now, but just know that that's coming later. That's kind of sometimes how I represent it. Okay, so what do I need to multiply? Pick one. Just pick one of the numbers on the top or the bottom and scale it up to the next one. Which one do you want to pick? 7, cool. So 7 times 4. So if I multiply both of these by 4 over 4, I get 7 times 4 is 28. 4 times 21 is 84. Oh, that's sad. Why? Because 28 over 84 is not equal to 28 over 63. That means they're not equivalent. Okay, so 7 over 21 is not equal to 28 over 63. Questions? So sometimes this works, sometimes it doesn't. Right? Sometimes you have equivalent fractions that can't be scaled. Like 2/3 can scale up to 4/6, but can 4/6 scale up to 6/9? No, they can't. But they are equivalent because they both simplify. So sometimes this works, but sometimes it doesn't. But this is a fast way, right? It makes it so we only have to do work on one fraction. So if it's there, awesome. If it's not, then we need to look for something else. Okay? Questions on this method? All right. The last method is called cross products. So read along with me. In the proportion A over B equals C over D, the products A times D and B times C are called cross products. The way that we look at that is, do you see that the two red letters, A times D and B times C? What ends up happening is we do this. And when I multiply those, what I'm really doing is I'm actually multiplying. So I'm just going to show you this so you guys can see where it comes from. When I multiply both sides by B, look what happens. What happens on the left-hand side? B will cancel. And I'm left with A equals C over D times B. With me so far? Now I want to multiply both sides by D. What's going to happen on the right-hand side? The D's will cancel. And what am I left with? I'm left with A times D on the left-hand side and B times C. And I can write it in any order, right? So these are what we call cross products. It makes it so we don't have to do this work every time. It makes it so we can go straight from the proportion, this red proportion, to this red cross product. Because this is where it comes from. What I'm really doing is I'm multiplying both sides by the denominators, right? That's what's happening. On the left-hand side, the B will cancel. On the right-hand side, the D will cancel. And so that's what I'm left with. That's called a cross product, okay? Let's do this. So we're going to be looking at, oops, excuse me. those two, then we'll be looking at those two. So let's read along. You want to multiply the denominator of one ratio by the numerator of the other one, and then vice versa. Do that for both of them. The denominator and the numerator by those ratios. If the two products are equal, then the ratios form a proportion. So what we want to do is we want to circle 8 and 9. What do those multiply to equal? 72. 6 times 12. Those multiply to equal 72. And since those cross products are equal, we know that 6 over 8 is in fact equal to 9 over 12. So it's kind of nice. Sometimes cross products are nice. They make it so we don't have to reduce both fractions. Do you see how this one would not be a good one for scaling? Because 8 times what gives us 12? 1.5. That's not nice. Okay. Now let's do the cross products of the next one. Like I said, we're going to be doing a bunch, like examples, and then you guys are going to try some. Okay. 6 times 9, what's that going to equal?
54.
54. 8 times 7 is? 56. Uh-oh. The cross products are not equal. Therefore, these two ratios are not equal. If the products are equal, then the ratios form a proportion. So when you do your cross products, if the cross products are equal, then the ratios form a proportion. Remember, cross products is not the only way to do this stuff. There's 3 methods, right? Cross products is one method. You can also see if there's a common multiplier. And then you can also write it in simplest form. So if you're ever unsure, this is the method that will work every time. If you're ever unsure, this method will work the best. Okay? Cross products is kind of a fast way to do it. This is my favorite way to do it, if possible. See if things are proportional, using just finding a common multiplier. Now, you'll notice that I write them as fractions, so if they're not written in fraction form, you're going to want to write them in fraction form. It'll make your life a little bit easier. Okay? It'll make your life a little bit easier. All right, so that's cross products. Questions on those 3 methods? There are 3 methods there. All right, you have 4 problems I want you and your partner to do, to just try. Try these problems, okay, with you and your partner. Make sure you write them in fraction form first, and then decide which methods you want to do. It's up to you guys, okay? Look for a common multiplier, put them in simplest form, or use cross products. It's up to you, okay? Make sure you write it in fraction form, okay? This one, a little tougher, so I would make sure you write it in fraction form, okay? When you do your cross products, if you can't do them in your head, just write out the multiplication, okay? I'm going to do these in multiple different ways. All right, I put the first 2 up there. That's how I would have done the first 2. Remember, there are multiple ways to do them.
Is it okay if you do like all
In other ways, yep. If you did it in other ways, that is great. There's my last 2. So why do you think I didn't do any math work on number 3? Why do you think I didn't do any math work on number 3?
Because 4.5 is proper and 6/9 is not.
Yeah, so can they be proportional? This is big over little. You with me on this? 4.5 is bigger than 3. Big over little. Can that be equal to little over big? It's not possible. No matter what, even if I scaled this up, right? If I multiplied this by 3, then this would be way bigger than 6. You cannot have things that are equal. If I flipped this, maybe. If I flipped it, it actually would be right. If I flipped it, if it was 3 to 4.5, notice, remember the order matters. Remember how the order matters? If this was 3 to 4.5 and 6 to 9, then they would be equivalent. But notice here, remember I said writing them as fractions is helpful? 1/2 over 1/4, 8 over 4. Now there were multiple ways to do it. I could have simplified 8 over 4 to be what? 2 over 1. And then I could have multiplied this by 4 to make it be 2 over 1. Many ways to compare them. Did anybody do it a different way other than this? Yeah, how'd you do it?
Okay, so I did 1/2 to 1/4, but I just divided them, so I just did 1/2 times 4 over 1.
Yeah.
I automatically knew that. And that was equal to 2, and then I knew 8/4 was equal to 2, so I just did 1/2 times 4 over
So Ashley just divided them both. Remember, when you have ratios, one way to simplify them is to find their value. And how do we find their value? You just do the division, right? That's how you find the value of those ratios. So she just did the division of both of them and said, and was like, okay, is this division the same as that division? That's completely a great way to do it, okay? That was her simplifying both of them. Okay, when you just do the division, that's simplifying. Okay? Questions on these 4? All right, here we go. Finish it up. We've got just a couple more quick problems. So when we have problems with words, we want to make sure that we write the labels. There's 2 ways I can write this. I can compare minutes to minutes and laps to laps. Or I can compare laps to minutes, laps to minutes. It honestly doesn't matter. In fact, I want you to be able to do either of them. So it doesn't matter. We want to write our labels to help us. So just for the sake of this problem, I'm going to write it differently than what you normally would have. So you guys probably would have written this as 4 over 2.4 and 16 over 12. Right? When you first read this, is that what you wanted to do? 4 over 2.4 and 16 over 12? Well, I'm going to write this slightly differently. I'm going to write this as laps and time. Okay? So what I'm going to do is I'm going to write this like this. 4 laps compared to 16 laps. Is that, in fact, equivalent to 2.4 minutes over 12 minutes? The cool thing about proportions is that you can write them horizontally or you can write them vertically, and they will be equivalent, which is kind of neat. So the question is, how do you want to do this one? Well, I don't want to simplify them because I've got a decimal. That's frustrating. I can't scale them because how do I get 12 to be 16? I can't do that. So I'm going to use cross products. So just to make this go a little faster, I'll tell you what those cross products are, okay? So 2.4 times 16 is 38.4. And we know what 4 times 12 is. What's 4 times 12? 48. So, the answer to this question, are these proportional? These are not proportional. I want you and your partner to do number 2. There's many ways to do these. Go ahead and set it up. It doesn't really matter how you set it up, as long as you're either comparing pages to minutes or you're comparing pages to pages. It doesn't matter which. Set it up however you'd like. The only thing you can't compare is 20 to 45, because those aren't even comparing anything to each other. Did anybody do 20 compared to 25? 20 over 25?
Yes, sir.
Great. I did it the other way because I wanted to show you both ways. Okay? So 20 over 25 would be 4 over 5. 36 over 45, you divide both of those by 9, you get 4 over 5. And you get the same stuff. Why would I not use cross products here?
Because the numbers are so big, it takes just a
Yeah, they're big. Don't do that. Try to find ways that will make your life easier. Remember, I gave you 3 different ways to do it, so try to look for the one that's going to save you the most time. In this case, these fractions are easily simplified. I say easily because they're multiples of 4 and multiples of 5. Now, if you did 20 over 25, you would have divided both of those by 5. And if you did 36 over 45, you would have divided those by 9. Okay? But did you get the same thing, that they're both proportional? Yeah, so if you wrote your proportion the other way, 20 over 25 and 36 over 45, you're good to go. Okay? Okay, last thing. We have to determine if x and y are proportional, which means we need to see if all of the relationships between x and y are equal. We have to see if the x and y's are all equal. Hello. Yeah. Sure thing. Allie, you're heading out. Can you head to the front office? Okay. She's leaving. It's fine. So let's get back to this. So we need to determine if all of these are in fact proportional. So as we look at the first one, what's really nice is that the first relationships, we have to see if x and y are equal to x and y are equal to x and y, right? We're looking to see all of those. Are they proportional? So we see, all right, 1/5. What does 2/10 simplify to?
1/5.
And 3/15. Great. So they all simplify to the same thing. Another way to look to see if they're proportional is to see if this relationship is the same for everything. Okay, but I think that it's easier and better to look at this over and over again. Because they all equal 1/5, that means that they are in fact proportional. X and y are proportional. And now we look at these. So we might have to do some division, that's fine, okay? So what do the first two simplify to? 2/6 simplifies to?
1/3.
1/3. 4/8. 1/2.
1/2.
6/10 is 3/5, and 8/12 is 2/3. So are these in fact equal? No, they're not equal. So we're comparing relationships between x and y. Later on, we're going to be doing what's called slope, which is comparing these. I'm going to let you know right now, these do have the same slope, but let's not focus on that for now. We're focusing on the relationship of x to y because we're being asked if x and y are proportional. Here, x and y are not proportional. Okay? Questions on that?